So today's lecture, this is the last part. We are going to discuss on how to start a DC motor, what are the braking types and characteristics, and about compensating winding and commutation poles, and some basic speed control methods. We are going to discuss why we are going this because, as I said, in the beginning, you have a kickback effect. I'm right. I told you any stationary electrical machines at the beginning, if you apply the full power, why full power? 220 volt here. Similarly, in your laboratory, you will have a DC power supply, which is 230 volt in the beginning. You apply the full power to the machine, you get a reverse current, and the reverse current will happen for a short period of time. So your power as well as your current is very high. Then after a few seconds comes down. So in order to avoid that, what we do? So this is my motor. It can be a series motor or a shunt motor. I use these called starters. I have a 2-point starter. For example, you can see there is a 2-point, 1-point, and second point. So these are the high resistance. So what I do in the beginning, I use this handle. I keep it in this position. This position, you can see lot of resistance is connected. So the current from the line, the supply, will come here, goes here, and touches this point and travel all the resistance. So I apply little current in the beginning. So the motor will start smoothly, not with a very high current. So slowly what I do, I move this contact from here to here to here. Finally, I touch here, it locks with this electromagnet. This condition, I apply the full current. It's clear to you? So I get a lot of drop, V is equal to IR here in the beginning. Then in few minutes of time, I put it here. So I cut all the resistance. So in the beginning, I start with a high resistance. Slowly, it's a manual. It's not automatic. I push the lever. I start with the point M and I move towards this terminal 4. And when I reach here, what happened? You can see this is also energized. This is an electromagnet. It's energized. When this conductor is coming here, it locks automatically. The same supply I use for energizing this one, and I apply full current. So in the beginning, I start the motor very smoothly by using a starter. This is called conventional starter, but nowadays we never use it because when a current is flowing through the resistor, it produces a lot of heat, a lot of losses, and this is a conventional technique. Now everything is digital, so we use electronics converters for starting. So these are when the invention was done. This is the invention. So when the invention was done, they used starters. So you can have a formula. You know the ES is given by E naught plus IR drop. Now what happened? E naught is given by ES minus IR. So now I make this resistance equivalent to lot of resistance. So I increase this resistance a lot in the beginning. Step by step, I come here. The resistance comes minimum. So I get the rated speed, rated voltage to my motor. So in the beginning, I apply slowly the current. At the end, I apply the full. Okay. This is called smooth starting of your DC machines, classical method. Then stopping, that's very important. Braking, as like your car. Your car, you run at high speed, you apply the brake, you bring the car to standstill or reducing the speed. Same we have to do with our DC machines. So you have two windings. This is my electromagnetic field winding, armature rotating winding. You can see I put a lever. This is called single throw. Listen my words. Single throw, one pole switch. You see only one possibility. I close it. I'm right. I close, I open. So when I'm applying the braking, what I do? When I'm applying the braking, I move this lever to here to dissipate the heat in the form of through a resistor. So what happens when the motor is changing from motor action to generator, or generator is changing from generator to motor? Lot of heat will be produced in the machine as a I square R. What I do? I connect a resistor and dissipate all the heat. This is called dynamic braking.